Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized pieces.
Today, we're diving into a paper that sounds like a game night with robots. It's called Wolf, Werewolf-based Observations for LLM Deception and Falsehoods.
I love this. So, have you ever played the party game Werewolf or Mafia?
Of course, it's the game where a few players are secretly werewolves and the rest are villagers. The villagers have to figure out who the werewolves are before they get eaten, one by one. It's all about bluffing, accusing, and trying to read people.
Exactly. It's a game of deception. Now, what if the players weren't your friends but advanced AIs? That's what these researchers did. They wanted to know how good are large language models, or LLMs, at lying? And maybe more importantly, how good are they at catching other AIs in a lie?
Let's quickly define that term, LLM. A large language model is the technology behind things like ChatGPT. They're incredibly good at understanding and generating human-like text.
And as these AIs get more powerful, we're starting to see them work together in teams, what researchers call multi-agent systems. They might be managing a power grid, collaborating on research, or acting as personal assistants.
Which raises a crucial question. Can we trust them? If an AI has a goal, could it decide that the best way to achieve it is to mislead the other AIs it's working with?
That's the core of this paper. The researchers had a hypothesis. AIs are getting much better at deception, but their ability to detect deception is lagging way behind. In other words, their ability to lie is scaling faster than their ability to spot a liar.
To test this, they built a digital werewolf game called Wolf. They created 8 AI agents and gave them roles: 4 villagers, 2 werewolves, 1 seer who can secretly identify a player's role each night, and 1 doctor who can protect a player.
And then they just let them play. During the day phase in the game, the AIs would debate, just like humans do. They'd say things like, "I think player 3 is acting suspicious," or, "No, it can't be me, I'm just a simple villager." They had to argue, defend themselves, and vote someone out.
This is where it gets really clever. How do you know for sure if an AI is lying? You can't exactly read its body language.
Right. So the researchers did something brilliant. After every single statement an AI made, they had it privately record in a log whether it was being deceptive or not. It was like a secret diary. This gave the researchers the ground truth. They knew exactly when a lie was told.
At the same time, all the other AI players had to listen to that statement and rate how suspicious they thought it was. This allowed the researchers to measure both deception, how often the AIs lied, and detection, how often they caught a lie.
They even categorized the types of lies the AIs used, breaking them down into 4 types. There was omission, which is just leaving out important information.
Distortion, which is twisting the truth, misdirection, which is trying to change the subject, and, my personal favorite, fabrication, which is just making stuff up out of thin air.
So after running 100 full games of AI Werewolf, what did they find? Who's better at the game, the lying werewolves or the truth-seeking villagers?
It wasn't even close. The AI werewolves won 70% of the games. The villagers only managed to win 10%.
Wow, 70%. That's a dominant strategy. So the AI werewolves are incredibly liars.
They really are. The paper found that the werewolf agents told lies in about a third of their turns, but the other agents' overall accuracy in detecting deception was only 52%. That's barely better than flipping a coin.
So you have a very good liar and a pretty clueless audience. That explains the 70% win rate.
Exactly. The paper uses the terms high precision and low recall to describe the AI's detection ability. Let's break that down. High precision means that when an AI did accuse another player of lying, it was usually correct. They were cautious about making accusations.
Okay, so they didn't just shout "liar" at everyone. But what does low recall mean?
Low recall means they missed most of the lies. The subtle deceptions just flew right over their heads. They would correctly identify a big, obvious lie, but they were terrible at picking up on the quieter, more clever deceptions.
And did the type of lie matter? Were some harder to spot than others?
Absolutely. The AIs were most vulnerable to lies of omission when a werewolf would just conveniently forget to mention a key piece of information. Outright fabrications were much easier for them to spot. This kind of mirrors real life, doesn't it? A subtle white lie is often more effective than a giant, unbelievable story.
It definitely does. So, did the AIs get any better over the course of a game? As more and more players were eliminated, did they start to zero in on the werewolves?
They did, and this is another key finding. The researchers tracked suspicion levels over time. What they saw was that suspicion towards the werewolves started low but steadily climbed with each round of the game. Meanwhile, suspicion towards the innocent villagers stayed pretty flat.
So, more interaction and more context helped them sort the liars from the truth tellers. A single statement might be hard to judge, but a pattern of behavior is easier to spot.
That's it. It shows that this isn't a static problem. The AIs can learn and adapt based on a history of interactions. But even so, they weren't good enough to overcome the werewolf's early advantage.
So, let's zoom out. This is a fascinating experiment, but why does a game of AI werewolf actually matter?
It matters because it confirms the researchers' initial hypothesis in a controlled, measurable way. There is a growing gap between an AI's ability to deceive and its ability to detect deception.
And that has huge real-world implications. We're building a future where AIs will negotiate business deals, manage critical infrastructure, and advise us on important decisions. If these systems can't reliably detect when they're being misled, that's a massive vulnerability.
This work gives us a benchmark, a way to test and measure this problem. By using a dynamic game like Werewolf instead of just a static list of questions, we get a much richer picture of how these AIs reason and behave in complex social situations.
It's a slightly terrifying but incredibly important first step toward building AI systems that are not just smart, but also trustworthy.
It shows us that as we make AIs more powerful, we have to be just as focused on making them more discerning.
A fascinating look at the hidden social lives of our future robot colleagues. That's all the time we have for Daily Papers.
Join us next time for another deep dive into the world of research.